Hello and welcome to video 1 of 3 on how to use the Arduino's DC motor. In this one we're going to be talking about how the basics of Arduino motors work and how the Arduino systems work, taking into account the breadboards, coding and the main board itself. So we're going to start off by talking about the board that is going to be used in this, which is the Arduino Uno. So that is going to be the first one that we talk about. So the Arduino Uno is primarily used to make a circuit. So it has numerous amount of pins starting on this side with the analog pins, which go from A0 to A5. These are not going to be used in the system today, but they might be used in future ones. We then have the power ones, which is 3.3 volts, 5 volts, and the ground. This one will not be used, along with these two. On the other side we have the digital pins, which range from 13 all the way down to 0. 0 and 1 do not regularly get used, but might be if you do a certain system. Again, won't be used in this one. Rarely ever use these. These are used to transfer things to other Arduinos if you have them, but it takes a lot of setting up to do. The digital pins, some of them, like 3, 5, 6, 9, 10, 11, have a little line on them. These are pulse width modulation, which is basically a type of... it's a method of reducing the power that's delivered by an electrical signal. So this basically means that it's not using as much power, but it can change it up or down depending on whether or not you need it to go up or down. So there is a ground on this side as well, so you have 3 grounds and 1 5 volt. That is very important to remember. You can't obviously just throw things into it, won't work, and all of the circuits that are done require 0 solder. The breadboards. These are the little boards that you get that have all little pins in them. So they look like this. So they include rows of 5 pins and a long row going all the way down to the bottom. So the pins that go along, these are the 5 pins. These are all connected in circuit. So these ones are connected, which you can see using this one, as in these are connected, but this is not connected here. This is a copper strip that is used to send the voltage all the way through everything. So this sends it through anything along there, so anything you plug in here will be linked to whatever you plug in there, or there, but it will not link to this one. These two are separate, along with this being separate to this, which is shown a bit more clearer here. These ones are the power buses, so these go all the way down, so you have positive, these go all the way down as you can see through this strip, and negative, again, these are not connected, and none of these are connected to these at all. So, now that we have actually gotten this, these are the rough basics. So we have the board with our numerous pins on them, and then we have the breadboards with all of the prototyping areas. So, let's get on to building a circuit. This is the main circuit that is going to be built for this episode. It looks roughly complicated, but it's really not. Everything that will be needed will be listed constantly throughout the entire thing, so that it will be easier to follow. And I'm not going to just describe what's going on here. Instead, I'm just going to move it along over here, and I'm going to start again. There will be an image showing the actual real-life version of these to go along with it, so it's easy to work out. So, to start off, we're going to want our Arduino Uno and a breadboard. It doesn't matter what size breadboard you use, there are numerous breadboards. You can use the mini one. I would recommend not using, as it has not got a power or a negative one, so I'd recommend not using that one, but you can use the longer breadboard, or you can use the shorter one. For this one, I'm going to use the shorter one because it gives me more space to actually show what is happening on this. So, for this, we're going to need two resistors, one that are both 220 ohm resistors, both of them. Going to need two. These are the resistors that we'll need. They will look different, and I will again post an image of them there. Going to need an LED. We're also going to need a DC motor, an NPN transistor, which is a PN2222. Again, that's going to be there, so you don't have to remember that, and a diode. These are going to be the things that we need, along with jumper cables, which on this system I just do like that. So these are my jumper cables. So let's start off by throwing this thing onto the system. So I'd recommend putting it here if you're doing it so that it's easier to follow. So you have the 3 pins all connected there. All 3, but collector, base, and emitter. Don't need to remember what they are. They are in this order. They do not change. Then going to take our diode. Going to rotate it this way so I can actually use it. And we are going to connect it to this pin. So it's connected from the cathode. Oh no, that's the wrong way around. The anode needs to be connected to the emitter. This is shown using the little white line. That is what is connected there. So we then need our resistor. This doesn't matter where it goes. Both legs are the exact same, but it does need to connect to the middle. So the terminal 2 is connected to base, and for the diode, the anode is connected to the emitter. They are the main connections. That is literally those used. We're then going to plug in the LED. So the LED just I'm plugging it in on this side so that it's easier to show that it is just simply a separate system. So that gets plugged into there with the resistor connecting to the negative and to the cathode to the negative terminal here. This is the negative terminal. You can see that it's all fully connected along there, along with all that being fully connected, and that. So this shows where everything is connected to, which is actually quite useful. Right, so we're going to move the motor over here so that we know where it is. Right, so we're going to now connect our little thing. So we're going to use black wires to show the negative because it does make it a little bit easier. So this connects, I'm going to move this down here, going to connect it here. Now yours will not look like this unless you are using Tinkercad, which is what is currently being used here. And we're going to connect it underneath the diode. Yeah, underneath the diode, right there. That is the negative connected there. We're next going to connect to the positive, so I'm going to change my wire color to red. And we are going to connect this to the other end of this, to the cathode, which is positive. Cathode positive, anode negative. That's one thing you need to remember. Negative, positive. Always really vital and important. Okay, so what we're next going to do is we're next going to connect this middle line here. To make it a little bit easier, I'm just going to connect this one to ground, because that is basically connected to the negative terminal. Because we have this, might as well just connect both of them to ground. So again, I'm going to change my wire to grey this time because it's closest to black. I'm going to move it down, along, and up into the ground terminal. So that is now connected to ground, which means that all of these are connected to the negative terminal along this line. So that's connected to negative, and the resistor is connected to negative. That's in the wrong place. That has to be connected to the collector pin, not the middle one. I got that wrong. That needs to be connected, so I'll just delete and type that bit again. So we connect it here along this pin here, the collector, and we connect that into the negative. That is where it's connected. That's where it stays connected. That does not change. Right. So next we need to have another power one, but this time I'm going to connect it over here just so it's easier to distinguish where it's going. Ooh. We're going to go down there, along, and up into 5V. So that is connected to 5V. So you have to make sure that you connect that to 5V. Could be easier to demonstrate it by just simply moving this down a little bit. I can make it easier. So that is connected. Ooh, I want to actually move. So along the same line here, you connect another positive wire. I'm going to move this one up because this one actually just goes to this thing. So they are not actually connected. So I'm going to move that up to show that they are disconnected. They are both connected along that line, with one connected there and one connected into 5V. That looks really, really stupid, but that's how it works. Right, now we want to grab just a random color. Doesn't matter. None of these colors actually mean anything. They just help it to be easier. So connected to this resistor, we want to move this all the way up into 3. So this is using the pulse width modulation one. It is not necessary, I have tested it. You can connect it to 2, but I'm not going to because it might be useful for other systems. So we're next going to connect our LED by just moving this over here, moving this all the way up because we don't want to interact with anything else. And we want to connect this into, oh, I missed that. Whoops. So we want to move it up, along, and down into 2. So this is the digital pin 2 and digital pin 3. That's where these two are connected. That is all of the wires connected for this. That is everything that's needed. So we're not going to use blocks, we're going to use text. Continue. This is the wrong code. So we're going to ignore this and we're going to just write it again ourselves. So we want to start off by defining integers. So these are permanent numbers that are used to define things. So we want to just define motor pin. Oh, where's my, there it is. Why am I not writing anything? There we go. Motor pin. This can be named anything. We want to call it motor pin equals 2. No, 3. Colon. So what this has done is this has defined the integer motor pin. So this could be called anything. You could literally call this Bob or motor or anything. So for this one, I'm going to call it motor pin because it's the pin that the motor is plugged into here. This is the wire that's connected there. That is the motor pin. So that's connected into 2. This is a read and write integer. So this means that you can write something to it and it can read the value of it. So it can read whether or not the motor pin is high or low, along with writing it to be either high or low, which is very necessary. This next one is a constant integer. So this is why I had the LED, because LEDs, I know for a fact that you can use constant integers. So this is so we're going to do constant integer LED equals 3. That is meant to be 2. That is meant to be 3. That is meant to be 2. There we go. So this is a read-only integer. So you can't physically change the exact code that is. That means you have to keep it like this. So that is what this is. This main area is where you keep all of your integers, then there's nothing else there. What we next do is we next do void loop. So this is our void loop. So this is where we put all of our setup. So the only setup that you ever really do is pin mode brackets LED output. Now, you don't have... Oh, I spelled that wrong. There we go. Right, so you don't have to call it LED. I could call this 2, and then we don't need the integer. But I find integers a little bit easier because it means that it's actually easier to follow through the system what is happening. It just makes it a little bit easier. So for pin mode, you need to make sure that you always have the capital M there, because otherwise it will not actually work. So that is all that we need for the void loop. No, sorry, this isn't void loop. I was moving ahead. This is void setup. So this is where you are setting up the board. Void loop, which is what is used now, is where we put all of our main code. So this code is very simple. Literally what we do is we digital write it. So this is writing to these pins. So we digital write brackets motor pin. So we are writing to the motor and we're telling it to be high. When it is high, it will be on. So the motor will actually spin. When motor is high, motor will spin. Simple as that. We do the same thing as well with the LED. So LED high. So this should make the motor spin and turn the LED to high. So we want to always end it with this. So this here starts the section for the loop. This here will close the loop. Always need to remember that. If you do something else, you can make more voids. I wouldn't recommend it because it makes it just a little bit more messy and just extends the code longer than it needs to be. These are always needed to end the line, but that's all it is. So what we're doing here is we're defining the LED to be an output signal instead of an input, like we would do with a button. So if there was a button on this, it would do pin mode button input because you're inputting a signal to it. So this is basically going to, so when LED is high, LED is on. Basically, that is what happens in this code. When the LED is high, the motor will be on. What I am going to do is, so there's a little thing here called the serial monitor. There is currently nothing in the serial monitor, and there will not be anything. But what I will do is I will do serial.begin. So this, and I'm going to do it at 9600. So this will begin the serial monitor at 9600 baud. Not sure what that does. So this is key to start the serial monitor. It will not actually do anything because there's nothing happening to the serial monitor to show anything. Absolutely nothing. So that is all the code that is necessary for this. So let's just hide the code, move this back along, start simulation. And when this is powered, as you can see, there's an on there. That is spinning, and the LED is on. You change the color to blue, orange, but I'm going to keep it on red because it's a little bit easier to see. So that is the system. All of that. That's it. When I stop simulation, it stops spinning and it turns it off. When I start it, turns it on and turns that on. That is the system. That is how it works. When you're using your Arduino IDE, so if I get that up now, where's my Arduino IDE? Ooh, that's interesting. Okay, well, when you use your Arduino, there will be a little button in the top corner that basically says, that it looks like an arrow, and you press that, and it will upload that onto the thing onto the board when you plug in your USB. That is everything for this system, and that is actually all that I'm going to be doing for this episode. This is a very simple thing running through the code. So you put all of your integers before everything, always. You put your setup where you define things as output or input. Do not have to do it for motor, it is not necessary. And you put your void loop is where you put all your code. You do not put your code into the setup. One other thing to note, do not directly connect this to power and ground. Do not directly connect this. If you do that, you will likely break your Arduino board. If you do it just straight to a battery, honestly, you'll just waste your battery quicker, and that's never a good thing. So that is actually everything we've got. That is the end. There is a little wired diagram here, so this shows everything. One of these is wrong. I'm trying to figure out which one it is. I'm basically just going to do that. That is the wiring diagram there. That is it. So you have our motor, a diode resistor, our little transistor. We have another resistor, an LED. Why is there another LED? So that's connected there. So that is effectively our system there. That is it. That is everything that we have. This is the wiring diagram. There will be an image of this properly. Everything that is needed for this, so there will be a diagram of the actual board along with a resistor diagram. All of these sheets will be linked in the description with pictures that you can print off if you need them. As it goes on, more will be added, but again, if you want them, you can print them off and you can just have them like that. Anyway, that is everything from me. This is our simple DC motor system where we just make a DC motor spin using a little bit of code along with turning the light on. That is it. More will be used with this system. The system will barely change. If it does, I'll update it. But that is all. Thank you so much for watching. Goodbye.